Hello and welcome to the TBM videocast. This is Jim Rush, editor of TBM Magazine, and we're excited to have Joe Savage of Southland and Doug Harding of the Robbins Company here today to talk about the Ashbridges project in Toronto. Welcome, gentlemen.
Hey, thanks, Jim.
Yeah, thanks, Jim.
So can you start by telling us some background and the scope of work of the Ashbridges project?
Yeah, so Ashbridges Bay Treatment Plant Outfall is a new outfall that will convey effluent into Lake Ontario, as you mentioned, in Toronto. So we're looking at around 4,000 megaliters per day of treated effluent. So very large scale project for one of the largest plants in Canada. There's two main categories of work. There's onshore and offshore. Onshore, there's a vertical shaft that's roughly excavated dimensions of 16 meters by 85 meters deep, so neighborhood of 280 feet deep. The tunnel component is roughly 8-meter diameter by 3.5 kilometers long. Beyond that, there's a cast-in-place effluent conduit structure on the surface that connects the plant to the shaft and tunnel works. And then offshore, there's actually 50 vertical risers to be installed with approximate dimensions of 1.5 meter diameter by 50 meters deep that will connect the tunnel to the lake. There's also some miscellaneous works involved with that offshore and onshore. But that about sums up the project there.
So what about the geology? Can you describe that and how that may impact the work plan as well as the equipment selection?
Right. So the tunnel alignment is in the Georgian Bay formation shale. So rock machine was selected, and I'll let Robbins speak more on that. But it is the entire alignment is in shale with limestone interbeds that can be much harder rock. Potentially up to 250 MPa. But in general, it's good rock quality and shale generally considered in more of a weak strength. Also some groundwater anticipated. So the machine had to be set up to deal with that. But I'll hand that over to Doug if he'd like to mention a few comments there.
Yeah, thanks, Joe. In regards to the machine, Jim, the machine is an 8-meter rock single shield machine that erects a pre-erected segment in the back of the shield. The diameter of the machine is 8 meters. It's got 17-inch cutters. Per the tender specification, a remanufactured machine could be utilized. So a machine that finished a project in Mexico was a little bit different diameter, a little bit larger diameter. So we manufactured new shields and used components from the Mexico machine. Because the machine was already in Mexico, we elected to remanufacture the machine in Mexico through Robbins Mexico and Robbins USA together. So the machine was rebuilt and remanufactured in Mexico prior to going directly to Canada. This was all basically pre-COVID when this started. So in essence, it was probably okay that it got stuck up in Mexico, because it was actually easier to get from Mexico to Canada than it was from USA to Canada. So we would have had big problems trying to get people in and out between Canada and Mexico, or sorry, Canada and USA. There was special features of the machine per the tender specification. It had to comply to ITA tech specifications. It also was defined as a potentially gassy because of the shale geology. So we had to set the machine up with gas monitoring and also Class 1 Division 2 specifications. Also, a couple other things that were interesting is that there was a lot of concern that groundwater would actually leach in from the lake because we're going under Lake Ontario. So there's a lot of capacity to do drilling and grouting around the shield periphery and also into the face. So there's onboard drilling, probe and grouting drills, and also the capacity or capability to treat the ground should the water actually be found. Was a vacuum segment erector, pretty much standard TBM from that as a rock machine, single direction type rock machine.
Okay. So what do you see as some of the more challenging or unique aspects of this project?
Yeah, so Jim, there's a few things there. Just the shaft depth is a challenge logistically with being in the neighborhood of 280 feet down to excavate that and manage and hoist all the equipment necessary for the project. In addition to that, just the scale of the tunnel, the amount of muck to be removed. We elected to go with Robbins conveyor systems. So we have a continuous conveyor throughout the tunnel and a vertical conveyor in the shaft, and then a stacker conveyor on the surface where we haul off the muck from there. But overall, we're moving over 174,000 cubic meters of material for the tunnel at a very quick pace. And related to this is the large tunnel annulus that's required for the project. So as we advance, we're pumping and placing grout behind the tail shield to encapsulate the installed segmental ring. So we have a large grout plant on the surface that batches and pumps this grout to the TBM and there through the lines of the tail shield, et cetera, into the annulus. So that's something we had to work with Robbins on as well. But it is a large volume. I think well over 5 cubic meters of material as you build that ring. So you're moving and placing a lot of grout very quickly. Beyond that, though, there's extensive work in Lake Ontario, the offshore marine component. So there's 50 risers to be installed, where you have a short working season in Ontario in the Northeast, where you're subject to wind and waves, and then winter. So there's a big challenge logistically to get all this equipment together and out on barges to perform the work with the environment we're dealing with. So that's one of the big challenges there, and definitely unique for the project. Beyond that, there's the riser connections in the tunnel. So once the tunnel's completed, we have to come back and excavate through the segmental lining, through the rock, and connect the tunnel to the bottom of the riser, and do that 50 times. So there's some logistics involved there that will have several mobile working gantries or platforms that will have to support specialized demolition equipment, as well as other equipment there to support the ground and perform final shotcrete lining in those areas. Anyway, that's probably about it there. There's obviously other things with this larger scale project, but that's what comes to mind at the moment.
Okay. Anything from your viewpoint there, Doug?
No, I think the unique challenges were really just the compliance of the spec. There was a pretty tough spec drafted by the owner. CSA compliance with the electrical. Other than that, it was a pretty straightforward job as far as the design of the machine and the capacity of the mucking conveyor system. We did have to twist the vertical belt as it did come up the shaft because the storage cassette main drive, splice stand were all on the surface, and as the vertical belt comes up the shaft, we twisted the head frame so it could align itself with the site layout. Other features of the machine, I think, or unique features of the machine were really just we had per spec a monitoring system. We had to monitor a lot of monitoring for the data logging of the machine, data logging of the drilling, and all that information we actually received here in Solon. So we could follow the machine, and if there's any problems at the site, we can work with the Southland PLC people and figure out, help troubleshoot the machine should there have been anything wrong. The other unique feature we probably forgot to mention or didn't mention, per the tender specification, the machine, because it's going to end up underneath the lake, the machine was destined to be basically disposed of at the end of the job and left in the tunnel. Depending on what Southland wants to do, the machine can be taken apart and taken back out of the tunnel. However, that's up to Southland to decide because of their schedule to put these riser shafts in that Joe talked about. But per the plan or per the spec, the machine was to be abandoned at the end of the job.
That's right. That's right. Yeah, no, I think the schedule dictates on that. So it's unfortunate. Yeah, you do have a large machine like this. It has to be somewhat abandoned. So the shields and some of that structure, there's just no quick way to deal with that. But hopefully other components, depending on the situation at the time, hopefully some of those components can be retrieved. But we're gonna see, at that point in the project, what makes the most sense, to plan that out there. So.
Okay. So what is the current status of the project? What kind of progress are you able to make?
Yeah, so it's well underway. It's been a journey here to just get the TBM on site and to get it assembled, launched. We did create a launch tunnel, a starter tunnel, to fully assemble the machine, and then work through all those challenges, right, to get a large, complicated machine like this going and producing. But now we're about 60% complete with the tunnel. And we've had some really good advance rates that you would expect with the Robbins rock machine. I think our best day was 46 meters excavated, so over 150 feet. So overall, we expect the tunnel to be completed as our anticipated overall duration in our schedule. There was some impacts related to COVID, which I think maybe we can mention in a moment. But yeah, we're well underway, and we're looking forward to a successful tunnel here with Robbins in the very near future.
Okay, Doug, any comments on that point?
Yeah, I think as Joe mentioned, he gives some credit to Robbins, but I give credit to Joe and his team. I mean, they're the ones that make that tunnel machine run. I mean, it is a good, strong rock machine, a lot of power on the cutter head. It's got 9 times 350 kilowatts, which is a lot of power for an 8-meter machine. But Southland's got a good crew there and good people, and they can make that thing run.
Excellent. Yeah, so we've heard about COVID a couple of times already. Obviously, that's presented challenges across every industry, everywhere. So how has the project team been impacted by the pandemic?
Yeah, we'd love to quit talking about this subject, but unfortunately, it's not over yet. And when COVID started really hitting, I think globally, we were still trying to wrap up the TBM, and Robbins was approaching the testing phase. So we did have some challenges to get through. We did perform a remote factory acceptance test online, where Robbins personnel, videoed and walked through the machine to perform the required testing. So that was done with our team in Canada and in US, while the machine and Robbins were actually in Mexico. So we were able to accomplish that and then ship the machine from Mexico via ocean transit to Canada, and then get it here assembled, launched, all during COVID, and then continue here with the tunnel. And we're still dealing with COVID impacts, pandemic impacts, whether it's our people, our equipment, and then materials. There's an ongoing supply chain issue and risk. And so, we try to plan ahead. We try to have contingency plans, but still having disruptions, especially with labor force locally, to maintain, a minimum we need to continue the work each day. So certainly an ongoing challenge, and we're hoping, that we'll get through this soon, but we're still dealing with it. So I don't know if Doug has any other comments there.
Yeah, I mean, I follow exactly what Joe is saying. We have the same issues. I mean, supply chain issues, freight issues, labor issues, subcontractor issues. And, we've been all fighting this for a long time. And we see it getting somewhat better, but for sure we're not out of the woods yet. And we just hope that this winter doesn't bring another wave of this stuff, but we'll figure it out. We'll cope with it, and just keep working it.
Yeah, let's hope it goes away sometime soon. So a lot of great information, gentlemen. We're about at the end of our time here, but is there anything else you'd like to add before we let you go?
No, I think that's it, Jim and Doug. I really appreciate the discussion. So thanks, and talk with you another time.
Yeah, thanks for the opportunity, Jim, and Joe. We'll see you down the road.
Absolutely. So yes, thanks again to Joe Savage with Southland and Doug Harding of Robbins for joining us today. I want to thank everybody for tuning in, and we look forward to seeing you on a future video soon. Thank you.